two angles, theta and gamma, are complementary if their sum is equal to 90 degrees. Now, I can restate that in terms of radians. Two angles, theta and gamma, are complementary if their sum, theta plus gamma, equals pi over 2 radians. See, I can say it that way because 90 degrees, pi over 2, same measure. Okay, so we have some identities involving complementary angles and their co-functions. So we'll look at the degree column first, and then we'll look at the radian column. For the degree column, we know that the sine of theta is equal to the cosine of 90 degrees minus theta. The cosine of theta is the sine of 90 degrees minus theta. The tangent of theta is equal to the cotangent of 90 degrees minus theta. The cosecant of theta is equal to the secant of 90 degrees minus theta. The secant of theta is the cosecant of 90 degrees minus theta, and the cotangent of theta is tangent of 90 degrees minus theta. So these are complementary angles, and we can take one and express it in terms of the other using the equality. Now, the second column is the exact same list expressed in radians. So all we've done is gone through there and replaced the 90 degrees with the pi over 2, the equivalent measure. So let's see how we can use these identities for the complementary angles and their cofunctions. Find the exact value of this expression. The secant of 35 degrees times the cosecant of 55 degrees minus the tangent of 35 degrees times the cotangent of 55 degrees. So I'm looking at the first term, secant 35 times cosecant 55, and I'm thinking I'd sure like to express these two in terms of the same trigonometric function instead of a secant times a cosecant. And I've decided, I'm going to use the, looking at the left column, the right column, the left column because it's degrees. I see that the secant of theta is equal to the cosecant of 90 degrees minus theta. I'm going to use that. So I'm going to re-express secant of 35 degrees as the cosecant of 90 degrees minus 35 degrees, right? Because 35 degrees is my theta. And don't forget to bring down the cosecant of 55 degrees, that's the factor, and then bring down the minus sign. Now let's talk about the second term, tangent of 35 degrees times the cotangent of 55 degrees. I'd sure like to express that as just one type of trigonometric function. I'm going to take the tangent, and I'm going to use the identity that says the tangent of theta is equal to the cotangent of 90 degrees minus theta, to rewrite the tangent in terms of the cotangent. So for tangent of 35 degrees, I will replace that with the cotangent of 90 degrees minus the 35 degrees. And then don't forget to bring down the factor of the cotangent of 55 degrees. Bring that down. Okay, now I'm much happier because I have cosecants on the left and cotangents on the right. Now, let's see what we can do here. What is the cosecant of 90 minus 35 degrees? What is 90 minus 35 degrees? It's 55 degrees, right? So what I actually have on the left side here is the cosecant of 55 degrees times itself. You see that? Cosecant of 55 degrees times cosecant of 55 degrees. Well, that's the same as saying that I have cosecant squared of 55 degrees, right? Because that's the same. The notation indicates that it's cosecant 55 times itself. Bring down the minus sign, and let's analyze the parenthesis for the next term. We have 90 degrees minus 35 degrees. That's 55 degrees. So what we have here is cotangent of 55 times itself, cotangent of 55, which is the same as cotangent squared of 55 degrees. Okay, so we're making some progress here. We have cosecant squared 55 degrees minus cotangent squared 55 degrees. So now I'm going to use a trigonometric identity. It's the Pythagorean identity involving cotangent and cosecant. I know that, let's see, what is that trigonometric identity? It is cotangent squared theta plus 1 is equal to the cosecant squared theta. Okay? So where shall we use that? I think I'll use that right at the very beginning where I have cosecant squared 55 degrees. I will replace cosecant squared of 55 degrees on the left. I will replace that with cotangent squared 55 degrees plus 1. That's what it's equal to, according to Pythagorean's identity. Then I'm going to bring down the negative sign and bring down the cotangent squared of 55 degrees. So now I have cotangent squared 55 degrees plus 1 outside of the trig function minus the cotangent squared of 55 degrees. Well, the two trig functions are going to cancel each other. The 1 is independent of the trig function, and it remains, and my solution is simply 1.